All right, so these notes are on comparing distributions using box plots. So we already know how to get a box plot using our calculator, but now we're going to have two sets of data, and you're going to compare the data. So what's really important with this, I'm going to change my color here to red to make sure I realize it's important, is that you must use comparison words, right? So you must use comparative words. So what I mean by that is when you're comparing the center and the spread, so whether it's mean or median, standard deviation, or range and IQR, you have to use comparison words like greater than, less than, higher than, lower than, even larger than, smaller than, bigger than, smaller than. Those are fine also, but comparative words, okay? Also, when you're doing the shape, make sure you use context. Okay, so let's go ahead and get started with this. So this example, we're only going to do one example, and then you're going to do an example together in class. So this says Jessica and Miguel earned these scores on a new computer game. Construct side-by-side box plots of the data sets, then use this display to compare the distributions. So we're still going to be using SOCs with this, but we're going to use comparative words. All right, so we need to put this data in our calculator, so let me pull up my calculator. You should have yours out and ready to enter the data. I'm going to move it over a little so it's not taking up most of my screen here. Okay, so remember to enter data, we're in statistics, so we're going to hit stat, we're going to hit edit. All right, so in list one, we're going to put Jessica's scores. So we have 30, 30, 32, 34, 35, 35, 35 again. I'm just looking at my screen to make sure I don't mess up here. 3 35s, a 36, a 38, a 38, 40, and 45. All right, now we're going to move over to list 2. So I'm going to toggle to, I'm going to hit enter to make sure 45 is entered. Now I'm going to toggle over. Now let's say that I had data in here already. So remember to delete any data. If you had data in list 1 and you needed to go away, toggle up to where it says L2 or L1, hit the clear button, and then hit enter, and it'll clear out everything in that list. Okay, I don't have any data in here. All right, so I'm going to put Miguel's data, 40, 60, 80, 82, 82, 84, 84, 85, 85, 87, 88, and 89. So I have 12 sets of data for both. Looks good. Hopefully I didn't make any mistakes. It doesn't look like I did. It's very hard to catch your mistakes if you aren't looking for them, because there's nothing that's going to be like, oh yeah, that's completely wrong. All right, so now I want to do a box plot, and I want to do a comparative one. So I want to see both on my screen. If you want to see them separately, that's absolutely fine. Just make sure that you're doing an axis that will show both though, right? You want to make sure. So I'm going to already make my axes here. I'm going to wait to see what it looks like first before I do it. Okay, so I don't know if I'm using the 5-number summary or if I'm using the mean and standard deviation yet, because I don't know if it's positively skewed and negatively skewed, or if it's symmetric. It doesn't matter which one you do first. You can write down all the data. I'm going to get all the data and just write it down just so I have it, so I don't have to go back and get it at any point. So I'm going to go to stat. I'm going to go to calculate, a 1 variable statistics. Now, remember, list 1 is Jessica's score. So this is going to calculate everything for Jessica first. Now I'm going to write that off to the side here. So I'm going to do Jessica. And once again, I don't know if I need the 5-number summary or the mean and the standard deviation. So I'm going to write down both. Mean, standard deviation. The mean is 35.6 repeating. The standard deviation is 4.250. Okay, and then I'm going to do the 5-number summary also, because I might need that instead. So the 5-number summary is, we have the min is 30. Q1 is 33. The median is 35. Q3 is 38. And the max is 45. All right, now I'm going to do the same thing for Miguel. Okay, and actually, no, I'm not going to do that yet, but I'll do Miguel's now. Miguel. Okay, so now for Miguel, I'm going to do, once again, same motions here, stat, move over to calculate, one variable statistics, but I don't want it for list 1, so now I need it for list 2. So if you look at the number 2 on your calculator, right above that on my calculator in blue, it says L2, and I'm going to change that by hitting second, L2, move down to calculate it, and now I'll do the 5-number summary and the mean and the standard deviation for Miguel. So I have mean, standard deviation. So the mean is 78.8, and then the 3 is repeating. Standard deviation, 14.358. And then I'm going to copy and paste this just to make it, I don't know if it's going to be less work or not, but okay. And then I'll erase all these. Yeah, I think it is. Okay, so now I'm going to get the 5-number summary for each of those, or for this, I mean, 40, 81, 84, 86, and 89. Once again, I could have done that second, but I don't know. I felt like having it right there so I don't have to look for it again. Okay, so now I'm going to get my box plots, right? So I'm going to hit second, stat plot. Okay, so I'm going to use plot 1 and plot 2. For plot 1, I'll do Jessica's data. Plot 2, I'll do Miguel's. So I need to turn this on. Yours is probably still on. Type, once again, I'm going to do that modified box plot, which is already highlighted. I'm going to go back up, go up. So this 4th one right here, it's already highlighted. I'm going to keep that. And then it's using list 1, which is great, okay? Now for plot 2, I can either hit second stat plot again or I can toggle up to plot 2. I'm just going to hit second stat plot again. I'm going to go to plot 2, and I'm going to turn this on. And it's already on modified box plot, but if it's not, I would change the type to modified box plot, which it is. And then for the list here, for the X list, I want to change this to list 2. So remember, that's under the number 2, so I'm going to hit second 2, and it's going to do list 2 now, okay? All right, so I'm going to hit zoom 9. Now, one thing that you're going to have to remember to do is that you're going to have to turn this box plot off, or delete the data for the next problem that you do if it's not a comparative one, okay? All right, so I'm going to get what this looks like. So I'm going to hit zoom. Actually, I'm going to hit second quick because that weird thing popped up. So now I'm going to hit zoom 9. And there are my box plots. So let's see let's see what these numbers are here, okay? Or what I need to go to and from. Well, I already know what I need to go. The lowest is 30 and the highest is 89. So I'm going to go 30 to 90, and I'll go by 5 tick marks, but I'm going to label only the 10s, I think. Yeah, that's what I'll do. Okay. All right, so I got to remember I'm trying to get this all in here, so I got to think before I do. Trying to get a straight line there. That looks good. Okay. I'm going to move it over a little so I can label it Miguel and Jessica off to the side once I do. Like over here, I'll label it Jessica and Miguel once I do it. All right, so I said I'm going to start at 30, and then I'll go 35, 40. What am I going up to, 90? Yeah, I'll spread it out a little bit more. Spread it out a little bit more. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Don't ask how I got that to go so well. It was luck. 40, 50, 60, 70, 80, 90. I'm going to label it right now before I forget. And these are computer game scores. So I'm just going to put scores. You can put more specifically computer game scores. All right, so now I need my 2 box plots. I'm going to hit trace. Trace. All right, so I'll start with the one up top, which is Jessica. I'll put Jessica right here. Jessica. Okay, so her first whisker's at 30. Put a whisker there. I'll move over to the right. Her Q1 is 33. So remember this tick mark's 35, so I'm going to put like 33 right there. And then I'm going to move to the right. Her median's 35, so right there. And her Q3 is 38, so before 40, right there. And her last whisker is at, move to the right, 45. So 45 right there. Okay, it's not beautiful, but I can fix it as I go there. Oh, it looks pretty good. All right, so there's Jessica's. Looks good. All right, and now I need Miguel's. Miguel. Okay, so I'm going to hit the down button so I can get to Miguel's data. Down. Okay, so I like to start from left to right. I'm not working from right to left. My brain doesn't do that. All right, so we have an outlier clearly at 40. And then move to the right. There's another outlier at 60. And then we move to the right. So we have a whisker here because this is the data that is not outliers. It puts the whisker there. So it's not the min. Notice it says X equals, but it's where the first whisker is. That's 80. And then move to the right. Q1 is at 81, so very close to it. Sorry, I know it's a little scratchy, but it's fine. Move to the right. Median's 84. It's right there. Move to the right. 86. So right there. And then my last whisker is at 89, so I'll go like right there and put that there. Teeny tiny. Meow, meow. Okay, there's my box plots. Okay, so I have my box plots. I have all my data there, so now I just have to do SOCS. So I'm going to start with S, which is I'm going to describe the shape of each one. Make sure you're using context words. So if they're the same, you can say both Jessica and Miguel's are positively skewed, negatively skewed, symmetric. If they're different, then you're going to have to write a sentence each about them, okay? So if we look at each one, okay, remember this looks like this, so she's negatively skewed, and this kind of looks symmetric to me. But if you said it was positively skewed because this looks longer, I agree with you, because if you look at mine, it kind of looks symmetric, but if you look at the graphing calculator, the right whisker is longer, right? So it's just that my drawing is not perfect, but if I look at my calculator, it looks positively skewed. And then on the other hand, Miguel's is negatively skewed. So that's what I'm going to say. I'm going to say Jessica's is positively skewed, Miguel's is negatively skewed. But I can't just say it that way because I have to use context. So I'm going to say Jessica's distribution of scores is positively skewed. While Miguel's distribution of scores is negatively skewed. Lots of writing, I know. There's a lot of dead air in this video. Okay, next we have outliers. Oh, all right. So if you look, Jessica has no outliers. So I'm going to say that. Jessica has no outliers. While Miguel has two outliers of 40 and 60. Now, if you didn't remember what they were, I can see, I recall, but if you can't remember, you hit down, and then you go back over to his outliers, and you can see that one's at 60, that one's at 40. All right, now I need to do center and spread, but I also have to explain why I'm choosing it, okay? So both of them are skewed and there's outliers, so we're going to use the 5-number summary, okay? 5-number summary is what is going to take over. So if one of them was symmetric and the other one was skewed, you're still going to use 5-number summary, okay? So I'm going to say, since, oops, my pen went off again. Got to get used to that. Since the distributions are skewed, with outliers. So it's with both, and you don't have to have both. I will use the 5-number summary. Okay. All right, so now for center, we are using median, okay? So, and remember, this is where we're going to use the comparative words, right? So I'm going to find the median of both. So if we look at the median, it's blue, I want it yellow. And actually, I want this a little bit thicker, okay. Median, where are you? 35, median 84. So I'm going to say that I'm going to use higher or lower or less than or greater than, right? Because I want to compare them. So I'll say Miguel's median is 84, which is greater than Jessica's median score of 35. Or I can say higher than, bigger than, okay? All right, or I can have said Jessica's score first and then said hers is less than or lower than, okay? So I'm going to say Miguel's median score of 84 is greater than, there's my comparison words. I want to make sure I use those comparison words. Greater than Jessica's median score of 35. Okay. All right, now we're going to do spread, which is last. We have to do range and IQR. We want to do both. All right, so let's look at their IQRs, which I didn't calculate yet because I didn't know I was using them. So we'll do range and IQR. A range and IQR. Okay, so let's see. Her range 45 minus 30 is 15. Her IQR 38 minus 35, which is 5. His range 89 minus 40, which is 49. And then IQR 86 minus 81, which is 5. So they have the same IQR. And then Miguel's range is greater than Jessica's range, right? So that's what I'm going to say. I'm going to say Jessica and Miguel have the same IQR. So that's comparing them, right? And I'll say of 5 because I want to mention what that is. But Miguel's range of, I forgot it again, range was 49. 49 is greater than or much larger than Jessica's range of 15. Okay, and once again, there's comparison words. So this is the same for the IQR and then greater than again right there. And once again, I could have used less than if I would have said Jessica's name first. Okay, so the next example is going to be done as a class. What we're going to do is we're going to play the game of greed. We're going to be rolling a dice. The game is explained on the left there. And then what we're going to do is we're going to collect the data into 2 groups. Those will be decided in class. It could do the left side of the room versus the right side of the room, or it can do, last names A through L, last names, M through Z, whatever. We'll decide how to divide the 2 groups based on what we feel like we want to do. We've done males and females before, but we're not going to do that. So whatever you choose to do as a group, that's what we'll do. And then we're going to create, we're going to collect our data. We're going to put it in our calculator. We're going to do a side-by-side box plot, and then we'll compare the distribution. So we're coming up with our own data in class for that second part. All right, go ahead and get started on your homework.